All right, so today what we're going to do is we're going to look at the last part of our analysis for our formal inference paper. And today what we're going to do is we're going to look at shape. So far we've looked at spread, we've looked at overlap. Now we're going to talk about, or spread and, I've forgotten already. Anyway, it doesn't matter. Shape today. So we're going to look at shape. Now remember when we first started this shift, thank you. When we first started this lesson, we looked at a little bit of a review about the shapes of distributions. We looked at those dot plots. Some of them were very pointed. We had a triangular one. We had the normally distributed one. We had the uniform one, etc. And that's what we're going to be talking about today. But we want to be able to talk about it in terms of your data from your comparisons. So we're going to look at some of these. You're going to see that the four pieces of it are identical to the others, right? You're going to make an observation. This is what I see. You're going to relate it to the context. Then you're going to show some math to back up your statement, and then you're going to relate it back to your research. That four-step process is going to build all of these paragraphs for you. So what we're going to do is just go to Education Perfect and look at some of these. So today, we're going to learn how to identify features of symmetry and distribution into sample groups, right? They're generally not going to be the same, so you need to be talking about each group separately. We're going to provide evidence for your observations. In other words, you need to make sure that you have numbers. You're going to relate it to the context of the situation. What does that mean for your data? And finally, you discuss your shape observations in a report. How do I write that up? Yeah? All right. So let's begin. So when you have your two sample groups, we've already analyzed the spread and the shift. Now we're going to talk about shape. And remember that when we talked about shape, we have two different things we're going to talk about. Symmetry. So are the things symmetrical, spread out evenly above and below the median? And distribution. How are they spread? How are they grouped together? Do you see clumps of data? And I have no earthly idea what any of these pictures have to do with that, but there they are. Just to make you happy. Yeah, puppies are distributed properly. I don't know. Anyway, so here we go. The first thing you should look at is you should always consider the symmetry of the data. And remember, symmetry means that you get like a mirror image. It doesn't have to be perfect, but it looks like a mirror image. And when things are symmetrical, they're generally symmetrical with respect to the median, right? That's that number in the middle of the box. Now this one is perfectly symmetrical. You see that one side is a mirror image of the other. Yeah? Now, we can look at symmetry in different ways and comparing these things. But if you always remember that the median is here in the middle, and then if it's symmetrical, that means it's going to be spread out evenly on both sides of it. Make sense? Okay. So shape is probably the easiest thing we're going to work with. So here we go. We have the height by gender, and we just have the males here, not the female data. But you see that the median is here in the middle of the box, and then the data spreads out pretty evenly on both sides. So we would say that this graph is symmetrical of around the mean. Around the median, okay? Now, do you see this red dot down here? Now, from last year, you might remember that. This is the mean dot. Yeah? And so you're going to always have the mean dot on your graph, and because it tells you something about the distribution of your data. And do you notice here that the mean dot is almost straight down below the median? That is an indication that you have symmetrical data. Because remember, the mean can be pulled either right or left by outliers. Yeah? If there's more data to the right, then it's going to be skewed to the right. More data to the left, skewed to the left. But if the mean and the median are very close together, then that means you're pretty sure that it's going to be symmetrical, right? Around the median. Make sense? Now, and if you look at the numbers, remember that when you're comparing these, just saying the dot's close enough is not good enough. You have to actually use the numbers and see how close they are together. So when you're supporting that, and remember, you don't have to do the math for that. The median and the mean are both given in your summary. Okay? And there's a box right there that you'll check on your graph to display the mean dot. So the NZ grapher will put it in for you. Mean dot. I love that. Okay. All right. So the value of the mean can change depending on how your data is arranged, right? Again, like I said, that your mean can be pulled to the right or left. Now the median is always the number where? In the middle. So it's not going to be pulled by your data points, but the mean can move. And so again, remember, if it's symmetrical, the mean and the median, now they say equal, but they're going to be close, right? Within a decimal point or two of each other. Okay? If there's an outlier to the left, that's going to pull your mean to the left, which means it's going to be skewed to the left. And you need to remember those terms, so skewed left. If the mean is to the right, that means it's going to be skewed to the right. Now this is a real example that they're using here. You can see just how pulling those few little dots, so just having three values, how if you pull them from one side to the other, how it affects the mean. But that's the true median, it doesn't affect it at all. Right? Okay, good. So remember those terms, skewed left, skewed right. Right, so here we go. Let's comment about the symmetry of this graph. Well, first of all, we see that the highest point is right at the median, right? So right in the middle, yeah? So if we were only looking at the median, we might say that this graph is symmetrical. But notice that the mean dot is further to the what direction? Right. To the right. And if you look at all this data over here to the right, that's what's causing that to move. So we would say that this data is skewed to the right. Okay? Now, to prove that, you would need to mention the difference between the mean and the median. We'll look at that, how to write that up in just a minute. Okay? So that's just your observation. There we go. So you can see the box and whisker, the median is longer than the box and whisker below the median. So you see that this side is longer than this side, yes? That tells you that if this side is longer, then it's skewed to the right. You can also tell that by looking at the mean dot. It's shifted to the right of the median. So in fact, we would not say that this one is symmetrical. We would say that it's skewed to the right. Okay? So it's really easy to tell. Now your job, though, is not only to make that visual observation, but you also have to give me proof of it using numbers. So let's see what that looks like. Oh, here's some more of them. Here, so if you look at this one, symmetrical or no? Yes, centered on the median. But if you look at this one is also symmetrical, but it has two modes. Remember, mode meaning the number that occurs most frequently. It has two modes, and they're centered around the lower quartile and the upper quartile. But it's still symmetrical. So you would say that this is a symmetrical distribution, but then you would have to say that it has two modes, one at the lower quartile, one at the upper quartile. This one is also symmetrical. But what do they call it when it's almost flat? Uniform, exactly. So this is a uniform distribution. There is no mode, there is no point at which the data gets higher than the others. So lots of different ways that things can be symmetrical. So it's important that you not only talk about symmetry, but you also talk about distribution. Okay, so here we go. We have some data here. It's spread out pretty evenly, so we could call this uniform. It has one mode. It's right there, but not really tell you much in this particular case. So even though it's a little higher in places, it still means there's still data spread out fairly evenly along the whole range. Yes? Do you agree? So this one would be a normally distributed. Okay? Here we go. A normal distribution has a center peak. That means this one is centered around the median. Okay? We would expect that this is the height of 13-year-old males. You would expect it to be centered around the median because you're going to have some short ones, you're going to have some tall ones, but most people are going to be around the same height. Yeah? This one was rolling a die, and if you roll a die, a lot of times you should start getting everything flattened out, right? So it should be distributed. This one is bimodal because we're looking at year 13 students, and one of them is for males and one for females. Which one do you think is which? The males are the taller ones, the females here probably, yeah? For year 13s. All right? And then there's a little group in the middle that overlap. Good. So you can also have trimodal. This one's called bimodal because it has two peaks, but You could have trimodal, but who cares? When you get to past two modes, we don't care. Okay, so don't even mention it. I don't know why they mention it. Yeah, so if you just don't worry about it if it's more than two modes. Okay, so here we go. We have some data that was collected. Let's talk about the symmetry. Is this symmetrical? I don't know. I think you could argue that it is symmetrical around the lower quartile and the upper quartile. I think you should say that. Certainly not uniform. Why? Because we have two distinct peaks. Yeah? So we could say that this one is symmetrical. It's not symmetrical around the median, but look where your mean is. Is your mean very close to the median? So even though you have those two sets, it's telling you that this one is relatively symmetrical, right? All right? Here's the mathematical proof of it right there. These two numbers are very close together. Okay? All right. So, now, they're saying it's slightly skewed to the right. I disagree because look how close those are. If you did those numbers, that's like a 43 and a 44. 1 unit apart. I would still say that this is symmetrical. Now, if you give enough evidence, then you could say it is skewed to the right. What evidence would you give? This box and this whisker are slightly longer than this one. The mean is slightly to the right of the median. So you could give evidence to say that this one is skewed to the right, and I would buy it. I wouldn't probably say this one's skewed to the right, though. It's so little. I mean, do you see that this is so little difference that you could also argue that this one is fairly symmetrical as well, right? Just be careful. Unless it's really obvious, don't use absolutes. So say fairly symmetrical, right? Not absolutely symmetrical. Always use qualifier words, okay? So this one is approximately bimodally distributed. It has two peaks centered around 20 and 70. That's what I mean by giving the numbers. So if you have a peak, you have to tell me where it is. Okay? And again, we're going to look at how to write that up in just a minute. Right now, we're just looking at the shapes. Okay? So you should always talk about symmetry, and you should always talk about distribution. Using one of these three words. Don't get carried away and make up your own language, please. Okay? So you're going to have some questions about that. But you're also going to have some questions where we're talking about describing. So let's go to that section really quickly. So now that you know what to look for, right? Uniform, symmetrical, not symmetrical. And if it's not symmetrical, it's skewed to the right or left. Okay? Distribution, either normal, uniform, bimodal. Bimodal is the third one. Okay? All right. Now, again, here's the same things. Your observation. What difference in shape do you notice between the two sample groups? Your evidence. Give the numbers to back up your thing. So it's exactly the same format. Context. So what does this mean for your data? And then finally, you go back to your research and see, do your findings agree or disagree with the research that you've done? And you make sure you cite the sources. Yes? Okay? Using your little numbers. So let's look at an example. Here are some test scores by gender, females and males. Okay, what do you notice about the females? Just an observation. It's okay. Beyond that, you knew that, right? So it's fairly symmetrical, but you could argue that it's skewed to the left slightly, right? But you would have to say very slightly skewed. I would go with symmetrical on this one, but you see the arguments, right? If you support it with numbers, then you can go either way with it. You'll have the numbers, you're going to know the mean, and you're going to know the median, so you can find the difference between them. If it's very small, then you could say the difference between these is very small, so even though it appears to be slightly skewed to the right, or to the left, to the left in this case, I would argue that it's almost symmetrical. All right, so you see, just use some soft language there. All right, what about the males? What do you think about this distribution? It's pretty uniform, isn't it? Yeah, it has one mode down, but it's way down here, so it's insignificant. Now the distribution, this one I would definitely say is skewed to the left. because look how much longer this side is, and the mean dot is pretty far over. Okay? So look at how they described it. The female data is more symmetrical than the male data. So do you see they're not saying it's symmetrical, they're just saying it's more symmetrical than the other. Because remember, you're going to be making comparisons to the two sets of data. For males, the mean is shifted 0.45 left of the median. And for males, it shifted 1.77 left of the median. So definitely for the males, it's skewed left, right? For the females, if that's less than half a point, I would really not say that it's skewed. So this means back in the population, again, remember, you're talking always about your sample, but when you make observations, you always talk about the population. So remember, that sentence is always the first part of this second part. We'd expect female test scores to be more symmetrical than males, and for males to have more low-scoring outliers than females. Low-scoring because it's to the left, right? Okay. My research agrees with this observation. One website I found claimed that males tend to display a wider range of academic performance than females. I also interviewed one of my previous high school teachers, and he said that low test scores tended to come from males. That is very not a good source, but oh well, that's okay. All right, teachers would know, but most teachers wouldn't say that, but we'll see. I certainly couldn't talk to that because we don't have any in here. All right, look at the second paragraph. The female data is approximately normally distributed. So remember, in this section about shape, you've got to talk about symmetry, and then you're going to have a second paragraph about what? Distribution, right? So there's going to be two paragraphs in this section. Usually we only have one. The female data is approximately normal distribution, and the male data is approximately uniform. The female data has a single peak centered around. Make sure you back it up with mathematics. Whereas the male data is fairly evenly spread with some outliers around 40. That's that mode that we were looking at. This means back in the population, we'd expect the female test scores to be normally distributed around that peak, and male test scores to be normally distributed between 45 and 80. That's just the range, yeah? That's where they're getting those numbers. This finding also agrees with my research, as I found a claim that males' academic results tended to be more evenly spread than females. So the research backs up the fact that you're getting a uniform distribution. Yeah? How's it look? Now, good. Again, it's going to make more sense when you have your own set of data. Now, here we go, talking about those paragraphs. All they're doing is showing you the exact same write-up that they just did, but this one allows you to highlight which piece is going with which piece. But they colored the other one, so you kind of need that anyway. And again, why two paragraphs? First one is about symmetry. Second one's about distribution. Okay? So two paragraphs with shape. All right? So what we're going to do is I'm going to give you an Education Perfect exercise. You need to make sure that you're practicing these. You also need to be sure that you're building yourself a Word document as you go that you can use as a template, right? And what you can do is simply highlight the parts that you know you need to put your stuff in, leave the parts that you know that you need to have that are identical, right? So like this part. Is there some part in that purple that I must have no matter what?
This means back in population.
Boom. That better be the beginning of that sentence. This means back in the population, comma, then you'd write about what you'd expect out from your data. So you see what I'm saying about building a template? Some of these phrases are non-negotiable. Do not get creative. Do not rewrite them. This is the best way you could possibly say this. Okay? All right. So I'll stop the recording and you go